Hello, and thank you for joining us. I would like to introduce Dr. Eliot Weiner to you. Dr. Weiner received his undergraduate degree in aerospace, aeronautical, and astronautical engineering from The Ohio State University and his PhD in mechanical engineering from the University of Buffalo. He is currently a professor at Iowa State University and the director of Virtual Reality Application Center in Ames, Iowa. Iowa State University's Virtual Reality Application Center, also known as VRAC, is an interdisciplinary research center focused at the intersection of humans and technology, aimed broadly at enhancing the productivity and creativity of people. The VRAC research community spans a wide spectrum of disciplinary experts with particular strengths in the state-of-the-art interaction technologies, including virtual, augmented, and mixed reality, as well as mobile computing, developmental robotics, and haptics interaction. Eliot is the founder of Visual Medical Solutions, LLC, based on medical imaging technologies. The uses of virtual reality and mixed reality are growing. Professor Weiner can give us an excellent viewpoint on where the Industry 4.0 technologies are going. Thank you for joining us, Eric. We look forward to what you have to share with us. Take it away.
Okay, thank you.
You're welcome.
We're waiting to see. There we go. All right, let's get started here. So thank you very much for inviting me to speak today. I really appreciate it. Big thanks to all the folks who are World Manufacturing Foundation North America who got this organized, particularly Jack Harris and Bob, and then Nick behind the scenes, and Teresa for introducing me. Really, really appreciate that. What I'm going to talk about today is kind of some visionary stuff. We'll get down in some weeds a little bit, but the future of manufacturing with extended reality. So I know the talk said mixed reality, changed it up a little bit at the end to be a little more encompassing, and I hope you'll bear with me on that. So whenever I start a talk, I always like to, a little background as to who I am. I know when I'm watching a talk, I sure want to know the person who's providing it has some expertise for real. So as was mentioned, I did get my undergraduate degree at Ohio State, so I'm a Buckeye. So I have to say right now, any University of Michigan people in the audience, you need to log off immediately because I cannot talk to you. Did my master's and PhD at UB, and I'm now a Cyclone. The big V there is the VRAC, the center that I direct. And then those other logos are 3 startup companies. So aside from an academic career, I've also started up 3 businesses, one still running today in medical imaging. I've worked at big companies. So I've had a span of experience in a lot of different places. My research interest broadly, a lot to do with the realities, extended reality, but specifically virtual, augmented, and mixed reality technology. Lots of graphics and simulation and rendering. I've done that for my entire career. Done a lot of work for my whole career in big data, machine learning, well before it was in vogue as it is now. And I have applications really kind of spanning all across. I really get kind of bored sometimes after a few years working in an application area. I like to jump onto something else. But I've done some with agricultural vehicles, medical imaging, command and control for our warfighters. I mean, really a nice wide range, and that keeps it interesting for me. The little brief introduction, the center that I direct right now. So we're across the university. We do about $2.5–3 million of business a year, which for a research center university is pretty good size. We have investigators from all of our colleges. And the meat of kind of our workforce, if you will, is about the 250 to 300 students, lots of graduate and undergraduate students doing research for us. And we also have a graduate program in human-computer interaction. So you can get your master's or PhD degree in HCI. And we administer that program also. The strengths of our center. So we really kind of focus on 3 big things. So one is building tools, using technology, but ultimately to build tools that will aid decision-making in the design of complex systems. And that can be engineering systems, medical systems, command and control. I mean, really, you name it. We focus a lot on real-time simulations. We can do pre-render like you would see in movies and photorealistic rendering, but often we work with our sponsors and our clients. We see it more of they want to know, okay, this is great, but what if I change this variable, or what if I made this change in the time? And they want to be able to make those changes in real time. So we really focus on decreasing that simulation sort of rendering quality, if you will, a little bit, but give you the real-time capability to make those changes and see them in real time. And then really simple but very powerful hardware interfaces. So we're going to focus on that to enable use these high-end technologies, but ultimately we don't want them to get in the way. We want you to just augment really what you're doing and keep the human in the loop. So a lot of what we do now, a lot of what I do now is extended reality. Some of you may have heard this term a lot. I'm going to spend a couple of minutes here going through and reviewing what this is. So extended reality, or XR, is really this umbrella term that covers all the different kinds of simulation technologies we have, from virtual reality to augmented reality to mixed reality. And really, it's the X. And the X can represent current technologies we have and future ones that we haven't even developed yet or just starting to come up with. And so there's things such as non-invasive brain interfaces, which would be like you put some kind of skull cap on or some kind of sensor on your head. It doesn't go into your brain, but it's going to pick up different signals off of your brain and be able to react to those. And we're starting to see a lot of research done in that area, some technology. That'd be a really futuristic type thing. But the ones we deal with now, and to give a real, to make sure we're all on the same page, which would be virtual reality. And that's kind of probably the most mature of all of these. And it's not really that mature because it's only been a few decades that we've had it. But in virtual reality, the definition that I use is where everything in around you, in the environment you're in, is computer generated. So it's completely artificial. You may experience it more visual, additional to visual. Visual is the primary way you're going to see it. We're going to draw every single pixel around you. You're going to see things in 3 dimensions. It can be stereo or not. Typically for me, virtual reality is a stereo thing. You're going to have that 3rd dimension. You may also there are some ways to do sensory, which is haptic, sense of touch. Spatial audio will do things with all that, really enhances the environment too. There are some that do a little bit with smell that's pretty advanced, and you can't really change it as quickly as we would smell things in the real world, but there are some olfactory systems out there that work on there. And ideally, virtual reality will get to this point where we do really span all the senses. And you can see a picture there from our C6. It's a 6-wall system. It's the highest resolution VR system in the world still. And you walk into this 10 by 10 room, the door closes behind you. We put images on all the screens, and still it just comes out. You lose where the walls where you're walking around. So that's one of the big reality technologies. Another one is that's really gaining a lot of popularity now is augmented reality. And we're going to talk about a different application, how all of you, or not all of you, but a lot of you were probably introduced to AR several years ago. But augmented reality is going to combine, it's going to real and virtual objects in a real environment, though. So it's going to run interactively. It has to run in real time. And that image you see in the upper right there is I might be holding an image marker. And we have some kind of mediation going on between me and the real world. So it could be a phone camera, it could be a tablet, it could be a webcam. But the real world is being taken in through some kind of camera, some kind of system like that. We're doing image processing it very, very quickly. We say we recognize that marker. And then, okay, you told me if I see that marker, I'm going to draw this 3D model on it. And the nice thing is, aside from drawing it, you also get the pose. So if I move that marker at different angles, that model is going to move with it. So that image you see there, to some people, looks like it's Photoshopped. It was created. That's a real image from inside of an AR system. The lower one is also all the red piping you see there, a little bit more photorealistically rendered, but that's all augmented content on top of an actual engine block. So you can actually create augmented reality simulations that look very real. And one of the big points of AR is that it has to be registered to the real environment. So if we didn't have a registration between our virtual content and where it's supposed to sit in the real environment, those pipes, for example, would not be in the proper location on that engine block. So that's a key point that's from the technology development that we have to have. Another one that came out of these two is mixed reality. And I apologize, we have for some reason one of those images not coming up right now. I apologize for that. But in mixed reality, it's a fusion of these different reality technologies. And ideally, you're going to have virtual reality, augmented reality with big physical set pieces. So you can see the picture in the lower corner there, a flat world that was developed by the USC Institute for Creative Technologies, or ICT. We have a lot of colleagues there. And this was for a command and control to help them work during Operation Desert Storm. You see there's a physical room there in there, and it's got broken furniture. This might be in an Afghan village or an Iraqi village. And they're looking out through a window, but that window is a screen. And then they can see projected out into what would be a town there. The one that I apologize for some reason is not coming up is the Mirage system that we built at our place, which was to again, study this kind of mixed reality. We have building walls and set pieces. We have televisions or high resolution screens in the windows. So if you're in a room and you look out the window, you'll see out into a courtyard, or you'll see out into a, the vast prairie or terrain or whatever you might see. The interesting thing about mixed reality is it really takes VR and AR to a next level, because you have to have tracking over a very wide range, sometimes very inside of rooms that have a very secluded, be difficult, and also a very larger area. You have to understand where people are, because you have physical assets, you have a virtual assets, and they have to all work together seamlessly. So there's a lot of back end sort of tracking and numerical computation that has to happen for the successful running of an MR system. So those are kind of the three technologies: MR, AR, and VR. And right now, that's make up primarily of what XR is. You're going to see some new ones coming up. But I want to take a little step back and see how new these technologies really are. So where was XR just a few years ago? And was this really the beginning of commodity interaction devices? And the key word there is commodity. If you look at some of these things, they look old. I mean, they really look old. If I see that magazine cover with Robert Downey Jr. on it, and he's sitting on top of an AR marker, that's the kind of marker that we used to use to register AR content in the real world. Now we have a lot of AR systems that don't even need markers. They can recognize natural features, let's say table corners, doors, windows, or we can use markers that are pictures on a wall, or that are already existing in an environment. So that computer vision and that recognition technology has come a long way. Google Glass was a big thing, and obviously that's disappeared. You still have the first down marker that you'll see in football games and things like that. Wii's were a big deal. We were doing a lot of research with the Wii Mote, and those are what the headsets and the Kinect. People remember the Kinect. Kinect was a huge thing. We used that for research for years and years and years, and now it's just gone. And when you think of the Kinect, I'm sure people are going, boy, that was a long time ago. It really wasn't that long ago if you look at the years. But what are we doing today? What are the capabilities today? And it's amazing in such a short period of time, from a commodity standpoint, how things have changed, and sometimes behind the scenes. So the iPhone 12 just got released with a full LiDAR scanner involved in it. Over in the lower left there is a portable ultrasound that you can connect into your cell phone, and allows you to do ultrasound technology, whether you're looking for, let's say, pregnancy or injury or something. But now you don't have to do it in a hospital or a medical office anymore. You can pretty much do it anywhere. The headsets look very similar, but their capabilities are so much more. So, a number of years ago, the first version of the headsets came out. If you wanted tracking, you had to set tracking cameras up around your space, and there was a lot of measurement and make sure that there wasn't vibration. Now, a lot of these systems actually have tracking built right into them. So, and they're trying to get away from tethering to a computer. And I do like to show the football one there, because what computer vision has allowed are these enhanced stats. So when you see things like, well, the throw, because the angle this receiver was at and where the ball's coming and the way he could see it and where the defender was, there's a 25.8% chance he's actually going to be able to catch it. There's computer vision that is automatically calculating all of this, storing this data and having it available for the future. Just whereas a few years ago, we didn't have this available. So these sensor capabilities, the commodity capabilities are just popping up in our cell phones, in our computers, in our HMD. It's just staggering. And the cost is a few $100s to maybe $1,000 sometimes. Whereas 5-10 years ago, it wasn't even available, or it would be tens of thousands or hundreds of thousands of dollars. So we have a really amazing amount of capability right now. Where are we going with it? Well, hey, if I could answer that, or you can answer that, that would be the $1 trillion question, right? That would be the $1 trillion answer, right? Would be a better way of saying it. But we're seeing something else going on with the marketplace right now. And this is where industry and the markets want to push research development. And those like me that have kind of lived in both worlds, it doesn't really work that way. So companies keep investing. We keep hearing about, there's going to be, this much billions of dollars in the AR market or the mixed reality market or extended reality or whatever you may think. But yet, if you look at over the next couple of years, or the past few years, what you will see is these charts really just keep getting pushed out. So originally it was, well, by 2020, you're going to see this. And then, well, not by 2025, not by 2030, then by 2032. Because the technology is coming along rapidly, but it's not coming along as rapidly, say, as the market wanted. But there are a lot of uses for it. So the big adoption has not happened yet, but you're starting to see it creep in. And I'm going to try and make this case for you right now as to where XR is going to come, how it's going to be in our society, and then how it's going to be used potentially in manufacturing. So I got to say, how do most people know XR? And if you've seen this picture, you're like, oh, yeah, that's right, Pokemon Go. So Pokemon Go, to a lot of us that work in the field, are like, we're so tired of seeing Pokemon Go. However, Pokemon Go really introduced the world to augmented reality. I mean, it's the biggest by far. But then a lot of people say, okay, it's a game. How much could it really do? Well, let's flip over to the business side of it for a second and take a look. So Pokemon Go just passed in July of this year $3.6 billion in lifetime revenue. Take a look at the growth chart on the left there and see how much revenue that Niantic gets from Pokemon Go from 2017 to 2020. That's an incredible amount of money. This is real. This is not some little video game they're making, people released and they're just making a few bucks off of. They are making massive amounts of money. This is a huge community. This is just one example. And this is why you're seeing cell phone manufacturers, you're seeing, Microsoft hardware manufacturers, and we're diving into this market because there's so much potential, they feel. Well, one of the markets they often go to is the video game market. And this is obviously where Pokemon Go lives. So let's talk about that for a second. The video game market in general is going to spend in 2020, there's about 2.7 billion gamers in the world, and they're going to spend just shy of $160 billion in 2020. That's an unbelievable market. And that's good from the aspect that it's thriving and it's doing well. From my perspective and the technologies that I deal with, it can be bad because this always seems to be the market that new technologies, people, it's going to go into gaming, okay, or it's going to go into sports. Well, we can do a lot more, and I'm going to make the case a little bit later on for like engineering and manufacturing, how we can do that. But this market in a few years is projected to pass $200 billion, right? And this is done by Newzoo, which is very well known for doing these kind of market forecasts and pretty accurate. From a technological standpoint, though, where is this going? How could this potentially be used in other places? Well, one of the big deals here is the rendering capabilities of some of these systems. So this is some graphics from PlayStation 5. This is using Epic Games' Unreal Engine, which is a game engine that we use often for projects. We use the Unity engine too. And take a look at some of those. These are all computer generated, so this would be more in the virtual reality realm. They don't have it in stereo, although with PlayStation 5, so a lot of their games you can wear their stereo headset if you want. But if you look at the detail, the shadowing, the coloring going on, the texture, even in that one in the lower left where you see that blur, well, that's because you're traveling in a vehicle at very high speed. So that's really what, as a frame to go by, what you would see if you're in a vehicle flying through or driving through. And you might be saying, okay, well, it's great. Why is that really useful? Because this is a console that costs a few $100s, and we can do this quality of rendering. Imagine and start, just keep that in mind. I'm going to come back to these kind of technologies a little bit later on and why they would be useful. Another big one where XR is you're going to see is marketing. I have a few videos here. I hope they play okay. And if not, I can supply, I have the links down there, and I can also email them to people. But just to get a little bit of an idea here of how they play, or excuse me, how they're using XR into marketing. So these are products. You see various ones. There's a virtual storybook that we're going to see there. The lower left one, it's about to play right now. That's kind of a pretty nicely done one for a product at a restaurant. So you pick up the little thing on your table, have your phone, and it kind of gives you, something about this particular product, this beer, something that they want to push. The other one here on the lower right was off a cereal box. So this is, they're using it a lot for brand recognition right now. It's a very cool technology. Kids really like it, and they're very adept to using it. But we need to break it out of just the games market, break it out of just marketing. And this is where I'm going to kind of make a statement of where I think this is going because of some of the projects that I'm involved in and also places that I've seen. So XR to me is not going to be a product in itself. I mean, there will be products, you will buy them, but it's going to become what I'm referring to as a fundamental technology. It's going to become ubiquitous, just like electricity, just like lights, just like water in our buildings. And I'm sure right now there are several of you or many of you that are rolling your eyes going, oh, come on. There's no way. This is just a flash in the pan. No, this is not. It really is not. And it's going to change manufacturing forever. And I'm going to show you why I believe that's going to happen. Now, I'm sure there's doubters out there. I love doubters. Let's have a conversation about it. But for the doubters right now, what I'm going to say to you is, need I remind you, did you ever think there'd be devices like this that you couldn't live without? And for many of you, if I took your cell phones away, and why we call them a cell phone, by the way, is sort of ridiculous because the phone portion of that is just an application on this device that can do so much more, but we call them mobile phones still. If I took your mobile phone away, how many of you would be like, I'd be lost. I wouldn't know where I was going or my meeting were. How would I get my email? How would I do So think about when cell phones came out and when this particular kind of cell phone came out, right? The iPhone was introduced in 2007. That was the first time we had a multi-screen, multi-touch device. That was 13 years ago. So in 13 years, we now have these things that many of us don't know how we would get by every day without them. You don't think XR can become ubiquitous like that? Think again. So let me go through a couple of use cases of where XR is being used in industry and outside of marketing, outside of gaming. So the Ford Motor Company is using it for design. Boeing uses it all over the place for assembly of actually some of the very complex wiring diagrams, and they have a whole, there's numerous things you can find. Paul Davies leads a lot of that effort. He's a good friend of mine from Boeing, does a tremendous job. We see Lockheed Martin and Porsche are using it for training, for quality assurance. And these are actively being used in their businesses every single day. It's not just a little project that's just launched up on one product line. It's being, in some cases, put across their entire enterprise. Not quite 100%, but it's getting there. And you're really starting to see these inroads because the improvements that you can get from XR are just dramatic. So let's kind of dive in to manufacturing. And let me try and make a case for you as to why XR can really transform things dramatically. So manufacturing and training, one of the challenges that I always, if I'm talking to people, I usually have people that have this kind of manufacturing expertise, as all of you have. But as many of you know, manual, labor and manufacturing isn't going anywhere anytime soon. We hear, those in the lay public hear about automation, robotics all the time, and we can implement that. It's terrific. But we know there's a lot of cases when we're doing manufacturing where the variances are just a little bit too much, where things can change a little bit much. And robots at this point, we don't have the kind of technology that can account for that. And so if I have humans, there's a limit, right? As a friend of mine, Jim Oliver, would always say, we're not going to spout a second set of thumbs anytime soon. So we're kind of stuck with how humans are. How can we increase their efficiency even more? There's training that has to happen, particularly if you're giving me some kind of work instructions, as they show there, they're very complicated. How do I get to those instructions? How do I understand them quickly enough that I can get on the line and be very, very productive? So my case that XR can revolutionize this for you. Now, I have to give account to the naysayers because I was actually working a number of years ago with a sponsor who brought in someone else from their company. And the first thing this person said, quote, seems like a lot of fancy stuff for my workers. Why can't we just use videos? This is ridiculous. I don't got to use graphics and these headsets and tablets. I don't need any of this. Well, and referred to Repair Clinic, this website that I use for any of us that fix stuff at home, right? You fix your refrigerator, your washer, your dryer, whatever. Repair Clinic is a beautiful site. There's lots of them over on YouTube too. You can find your exact make and model of product and someone doing it. However, for Repair Clinic, take a look on the lower image there. That's actually what it takes to produce one of those videos. It's a studio production, like a movie almost. And they shoot hours and hours and hours of footage that then have to be edited to create that video. And so are you going to hire a movie crew basically in your company? And by the way, if you want to make these changes on a daily, weekly, or monthly basis, you're shooting, that's the whole production facility you have to put up just for video. It's very expensive. You can't change them once they're done, and it takes time to create them and change them. It's not efficient enough. It's not going to get you where you want to go, which is really rapid changing to your manufacturing process, getting those changes communicated down to the floor, having them done almost in real time, if you will, and have the quality be very high and the errors be very low and the time be very quick. And that's ultimately where we want to get to. But XR for guided assembly can get you there. So these are some references for academic studies that have been done, and we've done our own too. And you see just really staggering improvements here. 8 times faster, 60% reduction in error, 100% improvements in speed. Other studies have shown 50 to 60% reduction in time in errors. It really is amazing. Now, I'm not claiming you're necessarily going to see those kind of improvements when you move to an actual shop floor or realistic environment. But think about it. If we're seeing 60, 70, 80, 100% improvements, let's say you even got half of that. Let's say I could tell you, you could get your products out the door 30% faster. That's incredible. You got to say, right? If you could say, that'd be amazing. What would I do? Because we're squeaking out, 2, 3, 4, 5, 10% improvements. This could really be a step function improvement. But I'm not going to claim it's easy at this point because it isn't. There's a lot of work that has to be done. So let's kind of go through when we deal with someone at my center, I get a potential sponsor who comes in, how we handle this. There's a lot of different form factors and capabilities you have to take into account. So we'll look at, If we're looking at XR, is it going to be a virtual reality trainer? Is it going to be an augmented reality trainer or augmented reality in situ on the floor? You're going to see we have HMDs, which are the head-mounted displays. HADs are handheld displays. We could use monitors, projectors. We can use smart glasses. There's still smart glasses around, not Google Glass necessarily, but other ones like it. And each is going to have tick off some different boxes, right? Depending on what you need to do. So tablets, for example, handheld displays are wonderful. They're powerful, they're big, they're portable, but you got to hold them. So you don't lose the hands free. And that's a big thing, obviously, if you're a manufacturer, you want to be able to have something where my hands are free. Okay. So to kind of move it along, let's look at some research questions. I'm going to take you down in the weeds now of a study that we did, a number of studies we've done to kind of summarize them. To kind of back up some of these claims that I'm making, does XR enable work instructions, let's say through an optical see-through HMD, where I am hands-free, really deliver more on performance, right? And how will users feel about that? Will they really enjoy it? And there's a couple of references from papers that we published on this that you can go and grab if you want, or contact me and I'd be happy to send them to you. So we built up a participant task here, and this was done with our friends at Boeing in a project for a number of years. And so it's a wing sort of prototype that you had to put together. And it's got complexity. It takes spars off the parts table there on the left and fasteners and different things from the parts bin in the middle, and then go over to the part assembly area. And there's wires you have to route through, and the spars you got to put in, you got to fasten them in. There's a lot that you have to do. And we did a lot of studies here. We had different modalities that were used depending on how we were looking at it. We started out looking at a traditional, we call a desktop MBI, which is the model-based instructions. So you have a work cell, you'd have a monitor over in that work cell, and you'd be looking at digital instructions over there. And the monitor was fixed. Then we had a condition we just took a tablet. So we took the same instructions. They're not interactive in any way. It's kind of like a PDF, if you will. You can scroll through them. And then you take it, but the tablet was movable around the work cell for you. Then we took the same tablet and we made it augmented reality. So we actually were shown where parts would go in real time. And then we did a study we used a HoloLens augmented reality device. So, and then we actually have one we also did with virtual reality. I'm not showing the results for that here. So we looked at all different modalities across extended reality. And you see, as we have here, and there's a little video it's going to play, and that kind of shows you what the AR mode would look like. You would press the next instruction. You get these little gates, if you will, that would kind of guide you to where you were going, whether it be the parts bin or the parts table or the assembly area. And then it would tell you, for example, the parts bin right there, just go take two of those of that fastener. So you don't have to remember a long part number or anything. You could just know that's where it is. And we did a lot of research figuring out, and you'd be surprised where inefficiencies would happen. In the desktop MBI, where they have the static monitor over in the work cell, just to go get a part, a fastener, people would take 3 and 4 trips back and forth because they couldn't remember the part number all the time. And for a lot of manufacturers, you don't want people having paper. You don't want them writing things down anymore. You want to keep it digital because it can change very frequently. So that's where the digital age is actually introducing inefficiency if they don't have it with them. And you can all see pictures in this slide of that's, where it would tell you how the spar, for example, would fit underneath. So we have occlusion going on there. Over on the left, there's a virtual reality version. This was in an Oculus Quest or HTC Vive. We did it in, so we actually did the same study, but entirely virtual. Okay. And the measures that we used, we looked at traditional measures such as how quickly did we get it done, how many errors. We also had something called more qualitative feedback, which was free response, as well as something called the Net Promoter Score, which was really used to figure out, did people enjoy it? And I'm not going to spend a lot of time on that. I can provide more information on that later if anybody is interested. And you can see on the right there, this is what our instructions would look like. And then we sort of had the score sheet that we went down. We were capturing all this information in addition to, we were tracking the users because they walked around the space. We saw in the work cell how much time they spent at the assembly area, how much time at the parts bin back and forth. We knew where their eyes were looking. So we're using a lot of technology to track them and figure out where the inefficiencies were happening, if there were any. So some quick results here. These are for the statisticians in the audience. We had a lot of statistically significant results, which was very nice. You can see right away that just putting it on a tablet really seemed to improve, really reduce the number of errors. The AR modes were very low. In fact, the AR modes, and we had statistical significance from our HoloLens AR desktop to the desktop MBI, which was that static desktop again. We had it with the tablet MBI. We also had it with the tablet AR. So any AR mode was very good. In fact, the AR modes were so good we actually hit a floor effect. As you see there, a lot of people the first time did it with 0 errors. So completely correct. They had never seen the assembly before. There's like 47 steps that set fasteners, wires, parts. Boom, did it the first time with AR with no errors really quickly. And it actually told us that our assembly, which when we first started studying, we thought was pretty complex, actually wasn't hard enough for these people, for our participants. We looked at completion times, and again, the HoloLens AR, the AR modes in general were just significantly lower, and you get things done so much quicker. We had a lot of people, as I said, do it really, really quickly in terms of time. And that really showed us, the improvements here. Now, one thing you might notice, as I mentioned, that Net Promoter Score, is if I go back to this one, you see that the tablet MBI, which was simply taking your work instructions and putting them on a mobile tablet, when we ran that study, which was a number of years ago, I was really close to telling the sponsor at the time and saying, you know what, you should just put all of we hadn't finished the data analysis yet. We were still working on it. But I wanted to give them and say, some low-hanging fruit, if you will. Take your instructions, put them on a mobile tablet, and that alone is going to improve your productivity. I mean, look how the number of errors dropped significantly. Even look at the improvement in time that they had here. There was an improvement in time. But as we were looking at the qualitative, the Net Promoter Score, and I don't have those results here for you, but we actually found out that people hated it. I mean, they hated it. Why? Because we took these instructions that were already complex, had a lot of writing, and we shrunk them down and put them on about a 10 to 12-inch tablet. So it made it much more difficult for them to read. And that alone ticked people off. And that was an interesting kind of fusion we had to do between the quantitative data, which was telling us they performed really well, but the qualitative data, they hated it. So do you want an unhappy workforce or do you want a happy workforce? And that's something that we, as a decision maker, you need to understand that. If you're just looking at things, the metrics such as completion time and errors, you're not getting the whole picture. And so that is another thing. This technology still has to be, used as a decision aid. It can't just take over. I'm going to flip over gears for a second because not only can it help you in delivering these work instructions, it can also help you create these work instructions. I mentioned before, you want to make those videos. They're very complex, took a long time. And so that was an issue with XR for a long time. If you wanted to create the work instructions, you were using CAD-like packages. You had to control every single step. If I had a part that kind of flew in and went underneath something, I had to create that animation. I had to understand the pose and the orientation and the keyframes, etc. So really, you don't want to hire a bunch of digital artists into a company to have to do this. So we started saying, well, there's a lot of technology. I've mentioned where it is, the LiDAR scanners and this commodity technology for scanning, computer vision. Why can't we use that? So we built a system that would do that. And we called it ARITA. It was augmented reality. At this point, it would be XR, but this is when we built it a few years ago. And so let's say you have a list of parts. You're putting a laptop. You're going to switch out the memory or hard drive or components of a laptop. You would take your expert. You would have the expert go and actually just do the procedure. They'll sit at their station. They do the procedure. But we're capturing what they're doing. I'm going to show you what that looks like in a second. We do a whole bunch of really complicated computer vision algorithms. I won't bore you with all of that. And we actually create digital models, 3D point cloud models of each of the steps. And then we can automate and refine it and create those work instructions that the previous study used. And you could do this. This generally took about 15 to 30 minutes more time than the actual assembly process happened. So your assembly process took about an hour. You could have the work instructions ready to go in about an hour and a half. Have your expert come in, do the procedure, capture it, process it, do a few little refinement steps, and then boom, you have your assembly instruction that can then be delivered to your tablet, to your HoloLens, wherever you want. This is what, in our lab, you see Lego pieces. We had to start somewhere, so we started with Lego, of course. But your capture setup is you're using basically a 3D camera or a sensor. It doesn't have to be extremely fancy. We've used the Kinect. We can use higher dimensional, three-dimensional cameras. We could certainly use a new iPhone that just came out. And you essentially define your area of capture. And the expert just works. That's their work cell. And they just go and do their work. And so we do, just to give you an idea of what we're doing behind the scenes, is you can see there on that desktop, the desktop there actually looks black. That's because we're actually subtracting that. We take a picture of the background environment, if you will, which is the table, the walls, the floor, everything. And then you start putting pieces in. We actually recognize their hands. That lower image there, you see all the little black pixels. So you put your hands in it calibrates to your skin tone and the shape of your hands. We remove your hands from the scene. So at the end of it, what we're able to capture is when the new part comes into the scene. And then we have a CAD library of the parts that are supposed to happen with this assembly. and we do some matching of the point clouds. And we figure out, oh, okay, this part that came into the scene, it was actually the base of this 3D printed unit or whatever the assembly is, and we build our steps from there. This is a project that we have, and so now we've developed a pipeline. It's not 100% commercial ready. I want to claim that. From a research perspective, though, we've done this on 3 different assemblies where we had an expert come in, put it together. About 30 minutes after the assembly time was done, we created the instructions. We handed it off to a system, and someone who had never seen it before did the same interaction being guided using XR technology. And so that pipeline has happened in research. How long as engineers, until we put enough money and time into it, that could potentially become norm industry? If you could deliver work instructions that quickly, changes that quickly to your workforce, how would that change things? And knowing that if you deliver it using an XR method, you might see 30% or higher gains in terms of reduction in error, in speed, things like that. So as we start to think about where that could go, how does it tie into this Industry 4.0 model? And I'm going to take it even a step further. If some of you, I'm sure, rolling your eyes, not going to happen. That's okay. I love critics. Let's talk about it. But I'm going to take it even with some more technology further. So there's a lot of sensor work being going on right now. And we do a lot of work at my center, because my center fundamentally, we do a lot. Data is what we do. We put data up and then we visualize it in different ways and we use it as decision aids. And so we have people building flexible electronics, building optical sensors for things such as human performance like glucose monitoring, electrochemical sensors for hydration, a lot of printed graphene electronics. And so let's take it, right now, that for human performance. What if your workers, when they put on their uniform to go on their shift, actually has sensors in it? We can detect, oh, hey, they're starting to get fatigued, they're starting to get stressed, or hydration's getting low. You should take a break. You should. This is what you should eat. Take this power bar, take this drink, or something like that to keep their performance up high. This is what athletes are doing all the time. But you're seeing a lot of people, right? Apple Watch is being used. There's a lot of wearables are being used for this. Start putting this down onto our workers, but we don't have to inject anything into them. It can be on their clothing to pick this up. We have additional kind of sensing. There's another professor who works at Iowa State, Baywin Lee, who does really high speed kilohertz 3D optical sensing with HDR. And I'm going to show a little video here of what he's able to capture. And so in that video of that fan blade, we can capture things up to, at this point, I want to say 20 to 30 meters per second that are about, I think we got to about 4 centimeters. So pretty tiny objects, or even lower than that, I think, in other projects that are moving very, very quickly. A lot of it can be done in real time. So those fans, depending on how fast they're spinning, you can actually capture them and you'll see that model in real time and then can immediately be used in an application. You don't have to sense it and then go away for 3 weeks and come back with a static animation. You can potentially use it right away. So if we put all this together, here's one of the visions that I'm working on right now is this idea of a real-time digital twin. And those people, oh, I've heard digital twin, you're rolling your eyes. Believe me, I'm right there with you. Because a true digital twin, a few years ago, we don't have the capabilities. Right now, on the cusp of having them. What if we have those sensors? What if I have a real facility and I put those sensors around that facility, capturing how it's working, capturing what my workers are doing, how their performance is? They're being delivered things potentially in XR. We're authoring the instructions in XR. I could walk around the facility with some kind of AR environment, glasses, a HoloLens or something, and I could see changes that are being employed or what the actual performance metrics are. Or if I want to make a change and say, oh, what if I spin this one up faster, that one slower? How does it affect my supply chain? How does it affect my actual production rate? You could also have a VR version of the facility running in real time. And the key thing is with the VR version, it's actually running. It's exact because all the inputs from the real facility are being fed into the VR version. So I could go in there, but now I can start making real big changes. What if I have to move the whole line around? I got to put a new line in. I got to shift everything around. Go ahead and do it. You're still pulling data in. Even potentially put in machine learning to give you an accurate prediction of how it's going to change. Now, I'm not saying all these things are available today. They're not. Some of them are. But in the next 10, 15, 20 years, is this what manufacturing is going to look like? It's going to change dramatically. Being able to test these things out and know what's going to happen before you move stuff around. Because we know once we get in that physical stage, and we have to actually move components, we're kind of locked into a lot of cost and time at that point. If we don't get it right, that's a big hurt. So kind of coming back to my argument that XR is a fundamental technology, I really think people need to stop thinking of XR as a product. It's really this technology like CAD was many years ago, and now CAD is just fundamental when it comes to engineering, design, and manufacturing. We had these same challenges with many of these things. I mentioned mobile phones earlier, computers, GPS, satellites. These are everyday things now that we use in everyday parts of our life all over the place. When they first came out, it was appeared to be a real niche kind of thing. Only high-end tech people were going to use very specific applications. And look at them now, right? Having a device that connects to a satellite for GPS, it's easy, right? Well, I mean, it's not, but it actually is now. It can be done very quickly. All right. So these technologies, XR in general, can dramatically change manufacturing. This idea that Industry 4.0, and we really have to computerize what we're doing from version 3, create your work instructions, deliver them, these real-time digital twins, and a lot of other things that I haven't even thought of, and I'm sure other people are. There's a lot of great research going on everywhere about this. So I think I'm all for my time right now. I thank you very much, and I'd be happy to take any questions you might have.
The question is, what kind of effort has been made to leverage this technology to accelerate interest in STEM and women in the STEM programs?
That's a great question. We get that quite a bit. So there's a big push. Leveraging technology, I will tell you, is where it's really is just sort of the neatness of it, if you will. We take this to high school, we take to elementary schools very frequently, and I mean, people see the AR, it's just like magic to them. Right? I mean, I'm holding this image in my hand, and I've got this 3-dimensional thing, and sometimes an animation, so things walking or moving or something, and it's incredible. And we use it to draw, and especially we need more work with underrepresented groups and women. And it's, look, you can build this too. And I haven't found yet the crooks that can really pull people in. It's sort of the things you already know. Is that a lot of us, we try and hire more underrepresented groups, more women in our groups, and then have them go and say, look, I did it, you can too. I'm at Iowa State. I'm in the Midwest. We don't have a great record of diversity. We're doing better, but it's amazing when I have, for example, one of my graduates, she's off working at Lockheed now, and I have her give a talk, and then I have a girl, maybe 12 or 13, said, I never knew that I could do this. Mm-hmm. And so it's heartwarming to hear that, but you also have to push it further. I think what dramatically help with this is to get this version of this technology into our high schools, into our elementary schools, to get the kids excited early, as opposed to by the time I get to be sort of high school age or end of high school or into college, like, my parents didn't do it, I can't do it. There's ways, but we haven't really done the leveraging yet.
Yeah, this is fascinating technology, and it's very appealing, I would think, to the high school student as well. Another question: how do you think VR will impact space mining companies?
Oh, that's a very specific question. Okay. I don't have a ton of, I've done a couple of projects. We did a project, at one point, we were supposed to simulate the conditions on Venus. They were going to build a device that was supposed to sit on the surface, and they couldn't create a physical testing chamber, if you will, that could experience those temperatures. And so that was kind of my one experience. And I know a lot of people that work in this area. I would say how it's really going to impact them is because your ability to experience that environment is very limited, right? So even now, if I'm manufacturing something, if I have the money and time, I can go create the prototypes and I can see if it's going to work. If I'm going to do something, let's say space mining, I can't just take a zip to the moon or over Mars and what I'm going to do. So simulation is going to be key, and not only simulation, but then putting someone in that simulated environment in a way where it feels real. And so I think when you get to those kind of applications, where getting to the physical environment is very challenging, simulation becomes ever the more needed, pertinent, but it becomes more difficult because we have a lot smaller data sets in which to create simulations from.
Yes, sure. It's fascinating how quickly the evolution of the next generation it reveals itself. Here's a question that popped up on YouTube. Can you see that question?
Yeah, I can. Yeah.
Okay.
What are the occupational opportunities and what are the required knowledge and skills to operate or maintain this equipment in a production environment? That's a great question. And that's one so there are absolutely job opportunities. This is going to open up a whole new realm. In fact, when we started the HCI graduate program, and this was back in 2003, we were really worried, was anybody going to hire folks with a degree in HCI? Microsoft came and snapped up our first graduate, and they go like hotcakes now to all the high technology companies. And so it's creating brand new job markets. If you think about usability UX design, 20 years ago, that was a real niche. There wasn't, there was some being done. Now it's one of the fastest growing job, segments in the world. You're going to see this with computer vision. You're going to see it with extended reality, the ability to code these systems, maintain the hardware, understand how to use them, train people on them. All the things you currently do with your new technologies, you're going to have new jobs for these new technology because it's going to be so pervasive, is my belief. Yeah, that's what I'd say there.
So I'm going to ask this from the parent perspective. So, for example, I have a daughter and I would like to guide her into possibly this career path. Where would you start? What types of studies would you make sure that she has a good tool belt of?
That's a great question. My kids are 15 and 20. So I've got, and they, I try and push science and engineering on them all the time. They're coming along, they make their own choices, but still, and I have girls, so I definitely see how the stereotypes come across, in certain families, for example, like, oh, girls don't do that still. Even in 2020, you still see that pretty prevalent.
Yeah.
So I don't have a silver bullet answer for it. I wish I did. But what I would say is there's so many uses of it. My youngest was kind of the one I'll give the example for. When I showed different variations, like some medical imaging technology on a tablet, we could do three-dimensional, we had augmented reality. Yeah, she didn't care too much about that. Try to get her into Legos, and Lego has their robotics kits and programming and really neat stuff. She really didn't like that either. But then we found this marketing thing. It was just a marketing thing, but it was an AR game. And she really got hooked into that. And all of a sudden, she got this Star Wars augmented reality battle set. She was a Jedi and she could battle. And boom, she was hooked. And then she started asking me, Dad, how do they make this? What do they do? A couple of discussions. Well, you got to understand, the physical, the real world, and how do we overlay this on top of it? And then you kind of go from there. So for me, the first step that I always tell is find that application that really they're just, wow, that's incredible. How did you do it? It might be on the back of a cereal box. It might be a video game. It might be a video you see on the internet. It could be a TikTok. I hate to say it. I don't like doing that stuff, but it could be that. There's so many things out there. And when you see them interested, talk to them about it. Find out what they're interested in. That's at this point the best I can give you. I wish I had something better, but there are a lot of education. People that focus on education research, I'm sure it give you a lot better answer than I'm giving here.
No, I appreciate that. And I value that. Thank you for that insight. We really appreciate that. Finding that niche, that it doesn't become a problem, it becomes a joy. So thank you, Eliot, for sharing your knowledge with us today. We really enjoyed having you as our guest, and we'll put your contact information up on our website so that if people have additional questions or if they need to reach out to you for any reason, they can have a quick link to you.
Sounds great. Thank you very much.
Thank you. Have a great rest of your day.
Okay, too.
Thanks.